Hello, 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 everyone, and welcome to this week's episode of Coffee with Thorben. I hope you had a great week so far and that you grabbed your beverage of choice. In my case, obviously, coffee. Let me quickly check why I can't hear myself. Can you hear me all right? Let's see. Oh, okay. Now I can hear me. Awesome. Good. So yeah, what's on the agenda for today? Last week I was asked by, I think it was Thomas. I'm not absolutely sure, but I definitely was asked about the mapping of JSON documents and JSON columns in your database with Hibernate. And I'm more than happy to talk about that today. I prepared an example, and yeah, as always, you can find all the resources that I'm mentioning in today's stream on torbenjansen.com/live. There you find links to all the live streams that I did this year. So this is the third one because it's just the third Friday this year. But I hope that we will get there to 52 live streams this year. Right? Maybe not all of them absolutely live. Might take a vacation. But yeah, at torbenjansen.com/live, you will always find the resources for that week's stream. And you can also find the recordings of previous streams there. So in case you have other things to do, like attending a work meeting or something, then you can go there later on and take a look at the recording and the resources that we used during the stream. So before we started the stream, Etesham asked if I could provide a roadmap for someone who wants to become a Spring developer. Well, that's of course a pretty broad topic, but I would try to give a quick rundown of what I think you should learn about when wanting to become a Spring developer. So first of all, you need to know Java, of course. Then I would recommend that you learn at least a little bit about Spring Core and Spring Boot, so that you get familiar with things like dependency injection, what actually is a service, and things like that. The next step then would be, well, either the API level with the REST API, for example, or the persistence layer. In that case, then my recommendation would be to take a look at Spring Data JPA. And if you're looking at that, also a little bit about SQL and relational table models and how databases work in general. Yeah, that's basically it. So if you put a little bit of time into learning about designing REST APIs and a little bit of time into persisting data in a database, and then a little bit into dependency injection, then you should be able to start working on Spring applications. After that, there are, of course, lots of other topics you might want to look into, but with these topics, you are basically set for the first few things. Okay, so let's dive into the topic of the first part of today's stream, and that is the mapping of JSON documents. Several years ago, we saw the trend of NoSQL databases, of unstructured data that had to be persisted somewhere. And well, that at that point in time, that wasn't that easily to be done with a typical relational database. And that was the reason why we then saw all the hype around NoSQL databases. All successful or more important relational databases then introduced some form of support for unstructured data if they didn't already have something like that. And we got in Postgres, for example, the JSONB data type, which is a data type specifically designed for JSON documents. And well, after that, the next question was, well, if we can handle that on the database level, is there a way to handle that also on the Hibernate level in our object relational mapping? And yes, there is, of course. And today I want to show you what you can do there. And if you want to dive deeper into these topics, I suggest that you take a look at my Advanced Hibernate online training, where we have multiple lectures that are focused on handling and mapping complex data structures, of creating more complex and advanced mappings and all these kind of things. Okay, let's take a look at the example that I have here, and that is actually part of the course as well. So you get a little bit of behind the scenes view at what you actually get with the course. So let's say we have a class called myJSON, and we want to persist this as a JSON document in our database. And you can see here this class is very basic. It has a string attribute with name string property and a long attribute with name long property. And well, as you might guess, these are string and long properties in the JSON document that we want to store in our database. So here we have a simple entity class, in this case my book entity, that gets mapped to the book database table. And down here we have an attribute of type myJSON, and I call it book description. Let's ignore the type annotation for now. I will get into more details about that soon. Okay, so if you want to map the myJSON class or objects of this class to values in your database, then you need to do a few things, because well, the JSON-B data type, as I said before, is a Postgres-specific data type. So it's no surprise that Hibernate doesn't provide out-of-the-box support for it, or that it's not part of the JPA specification, because it's not a feature that could be easily ported to other databases. But you can quite easily provide custom support for that. And to do that, you need to implement a user type with Hibernate. In theory, you should also be able to do this using an attribute converter defined by the JPA specification. Unfortunately, Hibernate has a limitation there and limits attribute converters, at least right now, to all types that are already supported by Hibernate. So you could take any Java class and map that to a type that Hibernate already knows how to persist in the database, so to any supported JDBC type. But you can't map it to a JSON-B type, because it's right now not supported by Hibernate. If you're using a user type, you can handle these kind of mappings. So to implement a user type, you implement the user type interface. And that interface defines the mapping between a Java type and an SQL type. So that's what we describe here. So we start with the SQL types method, which tells Hibernate what kind of type it shall use when it stores this object in the database. And the return class tells Hibernate what the Java type is that shall be instantiated. Okay, I just see that I got a question on Facebook. Aja, I hope I didn't butcher your name too badly. What might be the best possible way to pass JSON string to an entity class in Java? Let me show how to pass a JSON document to an attribute with Hibernate, and then we can talk about the mapping of a whole entity class. And I need to think about that for a moment. I'm not exactly sure if that's easily possible. But yeah, let me get to that a little bit later. So we implement our user type to map between the JSON-B column and the myJSON class. And well, after defining the two data types that we will use to represent this data in the Java world and in the database world, we need to implement two more very important methods. That is null safe get and null safe set. And right, these methods do exactly what you would expect by when you see their names. Null save get implements the get operation. So you get a result set, which means we had a query that was executed successfully. We got a result set back from the database. And now we need to map this result set record to an entity object. And there we have this result sets, we have the names of the columns, we have a reference to the session and to the owner. And now the question is, okay, how do we map this? First of all, we get the first element out of the result set. No, we get the element with the first name out of the result set to get the content of that value that we want to pass to a JSON document. So there we have it. That is the cell content that we had on the database. Be careful, the method is called null save get. So as the name indicates, it could be null if the database cell is empty. So we need to handle null, and that is pretty simple. If we get null from the database, then we set it to null in our Java world. If you need a different mapping, you could adjust that here. Okay, and then we use a JSON mapper to take the cell content and map that to the to a Java object. That mapping here, I use the object mapper from faster XML Jackson data bind object mapper. If you use a different library, then your mapping step would of course look a little bit different, but the idea stays the same. You take the JSON document, which is that part here, and then map it to the Java object. In this case, it's relatively simple because we just have these two attributes. There are no additional mapping information required. We just used the default mapping. But you could design this as complex and sophisticated as you prefer. Okay, next step, we need the reverse operation, the null save set. So now we take the attribute from the Java object, from the entity object, and transform it to a JSON document. And what we do here is we first of all check if the entity attribute is null. If it's null, then you need to call the setNull method on the prepared statement. And if it's not null, then we use a string writer and a mapper to actually create a JSON string based on that object. And we set it then at the index on the prepared statement. So this value will then be sent to the database in case you perform an insert or update operation. And then we have a few more technical methods down here. If you want to implement a user type, please take a closer look at the Hibernate documentation. But the general idea here is relatively simple. We need a deep copy. We need to identify if it's mutable or not. And a few other technical methods that are required by Hibernate. The interesting and important part that you should remember is that up here, that you implement a null save get and a null save set method, and that you define the SQL and the Java type for your mapping. Okay, so now we have our book entity with the myJSON attribute. We have a myJSON class to represent the JSON, the data structure that gets mapped to a JSON document. We have the myJSON type, which tells Hibernate, because it's a user type implementation, how this data gets mapped to, how the object gets mapped to a JSON document, which then gets stored in the database, and the reverse operation. What we now need is we need to define the mapping here and register the type. And we can do that in the dialect class. So we need to extend our PostgreSQL dialect and tell Hibernate that the type that we return from our user type shall be mapped to a JSON-B column so that Hibernate knows how to map the data type that is used in the database table. So when we provide our own dialect, we of course also need, let's go a little bit to the left, we of course also need to set the Hibernate dialect in our configuration to our specific Hibernate PostgreSQL dialect. I skipped over that pretty quickly. Implementing a dialect sounds way more complicated than it actually is. So what you can always do is you pick the dialect that is the one that fits the database system that you're using in production, and then just extend it. And if you take a look at the these dialects and step through them here, as an example. So here in PostgreSQL 9.4 dialect, you can see that the official implementation also just overrides the or provides its own constructor, and there registers functions, registers data types, and so on. So don't be scared about that. Just extend the latest version of the dialect and register your column type or whatever else you need to register. Okay, so now we have our user type, we have our database dialect that registers the mapping for the the mapping for the JSON-B column type. And now we need to tell Hibernate to use the user type that we defined for the entity attribute that we want to map, and that is here the myJSON type. And there are multiple ways to do that. You need to annotate your attribute with the type annotation, and then you could either provide the a reference to the fully qualified class name, or what you could do is you have a package info.java file, and there you can use the typedef annotation to register the myJSON user type that we just implemented to a logical name, myJSON type. And then you just need to reference that logical name here. If you have a user type that gets used in multiple places, I would always recommend to take this approach. So map that user type to a logical name and then just reference the logical name. If it's a user type that gets just used for that one entity attribute, then it doesn't really make a difference. Then you can just reference the fully qualified class name. Otherwise, it's a little bit annoying to always reference the full class name and makes refactoring harder than it should be. So in that case, just use a logical name. Okay, and I see that we have a few questions about the JSON mapping. Again, in the chat. Vidavati, thanks for providing the JSON code to convert the string to an entity object. So if someone wants to use the JSON library, then you can find the one-liner in the chat. The same object, Jan wrote, the same object mapper could be used to convert between the Java object and a string. Let me quickly check. So here I have one static object mapper in my user type registered that I use in both cases. When you do that, please double check with your library, with the JSON mapping library that you're using, if that thing is thread safe and everything. But yeah, you can basically if that's supported by a library, use one instance of it, which quite often is a good idea because it's relatively expensive to instantiate these things. And then Nikolai asked, I noticed that my JSON class implements the serializable interface. Is this mandatory and why? Well, that's a good question. It would only be necessary if we need the serializable, if we need to implement the serializable interface to map the object to a JSON document, and that then depends on your JSON mapper if that's required or not. In all other cases, it's not required. Okay, let's take a quick look at the test case. Where is it? There. So here my test class, I instantiate a book object, I instantiate a new my JSON object, set these two attributes on it, and call the setter method for the book description attribute on the entity class. And then I persist that, and down here I query the object. But let's start with that part first. And if we take a look at the log output, then can see here that the myJSON type wrote this log message, which we write here. Log info set value as the value of the JSON B cell, and that is the myJSON object, and this part here is just the toString output of the myJSON class. And if we go to pgadmin, let's refresh this real quick and take a look at the book table. Then we can see here that the book description column in the book table is of type JSONB and that it contains a JSON document. So as we intended to do, we now converted our object to a JSON document and stored it in a column of type JSONB. Let's go back to the IDE and take a look at the second part of the test case. Because there's something that I want to show you that makes working with JSON documents quite interesting. Postgres, for example, provides a specific SQL syntax to search within a JSON document. It's this arrow notation here, where I tell my database, okay, look, in the book table, there's a column book description, and that one contains a JSON document. And in that JSON document, there's a long property. And now please return all records in which this long prop contains the value 1, 2, 3, 4, 5. And well, it takes a little bit to get used to PostgreSQL's syntax to search within a JSON document. But as soon as you got familiar with it, you will quickly recognize that this is actually a pretty powerful feature, which makes it very easy to implement most of your use cases, even though parts of the data are stored in the JSON document. And one important thing here is this is a database-specific syntax. Because of that, it isn't supported by JPA's JPQL or Hibernate's HQL query language. But what you can, of course, always do is you can create a native query. And then you can use all the SQL features supported by your database because Hibernate just takes this string and sends it to the database. And because I'm selecting all columns from the book table, I can then tell Hibernate, please map this result set, well, each record in the result set, to an object of type book. And because book is an entity object, Hibernate takes the mapping information for that entity class and applies it to each record in the result set and maps each record to a book entity. And you can see here that's the SQL statement that we executed. the myJSON type, the myJSON user type gets again called, and we read this string here from a JSON B cell, and we then set it as a value on the book object. Okay, that's a quick introduction to the mapping of JSON database columns with Hibernate. Based on this approach, you can support each and every database-specific JSON, XML, or whatever user type, a data type with Hibernate. As I said, if it's a type that's not directly supported by Hibernate, as JSONB, for example, then you need to implement a user type, at least for now. That hopefully changes in one of the Hibernate 6 versions. But as of now, this is only supported by user types. In the future, it should also be supported by attribute converter, which are a little bit easier to implement. If you know the articles and videos that I did about attribute converter, you know that all these technical methods down here, the deep copy is mutable, assemble, replace, and so on, are not needed when you're implementing an attribute converter. There we are just focusing on the transformation from the database representation to the Java representation and back. Okay, any questions about this? Okay, if you have any questions, post them in the chat. And I take the chance and talk for a second about the last week and all the new stuff that's in the pipeline. So over the last few days, I started working on the Spring Data JPA video course. I'm pretty optimistic that we can launch it in the first quarter of this year. As you know, there's already some content about Spring Data JPA on the blog. And well, I've been using it for a while, so most of the content there is, of the course content, should be relatively easy and straightforward to prepare. If you're on my email list, then you already saw the outline. So we will talk about general information, what is Spring Data JPA and why do you need that. We will only very roughly mention the mapping features provided by the JPA spec. And then we will dive deeper into query capabilities, about the no-code repositories, all the usability features that Spring Data JPA provides on top of JPA, but things like how to integrate it with Query DSL. We'll talk a little bit about how to test your Spring Data JPA persistence layer, stuff like these. I hope I can share more details and probably an early sign-up option within the next few weeks, probably at the end of next month. Okay, let's see. Okay, I hope we are back. Sorry for that. My OBS crashed. But I think we are back. Right? Let's see, are we back online? Okay, seems like we are back. Awesome. Yeah. Again, sorry for that. My OBS crashed. That wasn't expected. So where was I? I was talking about the Spring Data JPA course, and I wanted to get real quick into the content that you can find on the blog and that we published this week on the YouTube channel. So on YouTube, I uploaded a video about DTO projections, why, when, and how you should use them. A very important feature, especially from a performance point of view, because using the right projection often makes the difference between an application that's scalable, that works really well, and has good performance, and something that's just sluggy, incredibly slow, and sometimes even unreliable. So with Hibernate, you should always make sure that you use the right projection, and that would be for read operations, DTO projections, and for write operations, it would be entities. And well, in this video from this week, you can find it, as I said, on the YouTube channel. We talk about the DTO projection and the best ways to use it. And what I personally found especially interesting this week was the blog article. You might have seen it on social media or on the Hibernate site and in the Hibernate release announcement. The Hibernate team released a reactive version of Hibernate in mid-December, beginning to mid-December. And well, between the years and at the beginning of this year, I played around with it, gave it a try in a few test projects, and I now published the first article on it, in which I show you how you can use Hibernate Reactive to implement your persistence layer for reactive applications. The interesting thing with Hibernate Reactive is that it's based on Vertex and that it applies all the features that you know from Hibernate ORM, or almost all of them, to the reactive world. Let me scroll down here a little bit. Here you can see we are working with a Hibernate session, and based on that session, you can perform all the usual operations that you do with Hibernate ORM as well, like persisting entities, like finding them by primary key, or like executing JPQA statements. And with Hibernate Reactive, you can either use Hibernate using the Mutiny API or the completion stage API. And yeah, if you want to dive deeper into that topic, make sure to take a look at the article from this week. And right, based on that, let's go to the next topic, which is the question of the week. In this part of the stream, I usually answer a question that I either got on social media somewhere, or that was posted on the blog, or that I found on Stack Overflow and thought this is especially interesting. And this week, I answered a question about polymorphic associations. That is something that I get asked quite often. Here, the thread opener had a question. They have an entity A, and that has a one-to-many association to entity B. And now they added an entity called entity C and wanted to model the association between A and B and the association between A and C. And the first approach that they wanted to use was, okay, let's use this one-to-many association and let it contain both associated entities from entity B and entity C. And where they ask how we could do that with Hibernate. And If you go to torbenjansen.com/live and go there to today's post for this stream, then you will find a link to this question. So if you want to follow along, please go there and take a look at it. And while you're there, if you like my answer, I would highly appreciate it if you give it an upvote. Okay, so there are two ways to solve this mapping. The most common approach would be to split the two associations and do one association mapping between entity A and entity B and one between entity A and entity C. And that's what I do here in the first mapping. That is a pretty straightforward and simple mapping. We have a one-to-many annotation on an attribute of type list of entity B, and we have the same down here with entity C. Because this is the one side of the one-to-many association, this is the referencing side, and it gets mapped by an attribute called entity A on these two other entities. And then the thread opener had these cascade and often removal settings on the initial association, so I kept them. But there I would recommend to be very careful and to review them before deploying this to production. Often removal and cascading should only be used if you have a parent-child association. So typical examples would be an order with an order position, a chess game with all the moves, and these kind of things. So where the child depends on the parent and is not a totally independent entity. If that's the case, then cascading and often removal is most often totally fine. If not, then you should avoid it because it can cause lots of issues, in worst case, even the loss of data. But even if it's a parent-child association, you should think twice about using cascade type all and cascade type remove, because the performance quite often isn't that great. If you cascade a remove operation, then Hibernate gets all associated entities from the database and then removes each and every one of them with its own lifecycle state transition and its own SQL delete statement. And that can cause performance issues. Option 2 for this mapping would be to use a polymorphic association. And that is what the thread opener was specifically asking for. I provided option 1 first because it's the more common and easier approach that fits more of the that just fits more domain models and more use cases. And based on experience, I would say a lot of questions that are asked like this actually are looking for option 1 and not option 2. Because for option 2, for polymorphic association, you need an inheritance hierarchy. Your entities, entity B and entity C, need a shared superclass. That could, of course, be one of these two entities or a different one. But if entity B and C belong to the same inheritance hierarchy, then you can use JPA's inheritance mappings and use inheritance type joint or single table to map them to the database tables. You can find a link on my blog, which are also linked here, about the different inheritance types mapping provided by JPA. But in general, with joint and single table, you get pretty decent support for polymorphic queries and associations. So if we have this inheritance mapping, then we can define a polymorphic association, and well, that's pretty simple. The interesting part in most mappings is this inheritance mapping part. The association itself is just a typical one-to-many association. We are now referencing the superclass. I called it here the super entity. And then Hibernate will do everything else based on the entity mapping. So if we then read entity A in our application and call the getter method for our super entities, then Hibernate will get the all associated records that get mapped to either the superclass or any of its subclasses, instantiate the specific entity class for that, and return it as a list of the type of the super entity. So let's say super entity is the superclass of entity B and entity C. And entity A is associated with one instance of entity B and one instance of entity C. Then Hibernate would retrieve all these information from the database with a statement that then depends on the inheritance type that we reference up here. And then Hibernate retrieves the records from the database, and for each and every one of them, it checks, okay, to which entity class does this record, has this record be mapped, and then Hibernate instantiates the record, so the entity object. So our entity B would be of type entity B, and our entity C record would also be of type entity C. And Hibernate handles all of that totally transparently. OpenJPA, the Eclipse link, of course, as well. This is standard JPA feature. Good. Any questions about this? Or any other questions about Hibernate? Because now we reached the end of the stuff that I prepared for today's stream, and we can use the rest of our time, which is about 15 to 20 minutes, to discuss your questions if you want. What do you think? Any questions? Looks like we lost a few people during the crash of the OBS and the resetup of the stream. There we have one question from Kirill. Yes, how to implement DTO mapping with Spring Data JPA? There are various ways to do that. Let me open up an article about that, and then we can go through the different options. So there are two things that I want to show. First of all, the mapping that you get with JPA standard features, and then the things that you get with Spring Data JPA specifically. So Spring Data JPA is a layer on top of JPA, so you can use all JPA features. In quite a few situations, it's just easier to use the Spring Data JPA features instead of the stuff provided by JPA. So did I open the right? Might have opened the wrong article. I think this is the one that I wanted to show. Yeah, let's say we have this book with author names DTO class, a very basic class, just a few attributes, but that's how DTO classes should look like. It should be just a very efficient representation of the data that we need for our use case and nothing fancy or complicated. So with JPA, you would need such a constructor expression. So in a JPQA query, you do a select new, and then you provide the fully qualified class name and define a constructor call. That means then you do an opening bracket, and then you provide all the entity attributes that you want to provide to the constructor call. Hibernate then uses these entity attribute references to generate the SQL statement. And you can see here that Hibernate just selects the different database columns mapped by these attributes. And well, Hibernate then gets back an SQL result set, and then in a post-processing step, instantiates via reflection a new book with author names object by calling the constructor that we described here. So this is the general idea, and that is what's the basis of everything that we will do. And then we can use the same with the criteria API. There we just need the construct method of the criteria builder, and that one then does basically the same. Same query, same post-processing step, just different API. And with Spring Data JPA, you can do the same. Right. You could use a query annotation and provide your own query with a constructor expression, but let me see. We have an article that shows how to use this with Spring Data JPA, and then I have directly an example that we can use to take a closer look at. That should be the article. Okay, so this would be the approach that I just mentioned. So you create your repository, in this case, the author repository, and then you have a method in your repository, find by first name, and you annotate it with a query annotation and provide your query, and that query uses a constructor expression to define the instantiation of an, what is it here, author summary DTO object. And that works totally fine. But there are easier ways to do that. And as long as your DTO class has just one constructor and its parameter names have the same name as your entity attributes, then you don't need to provide a constructor expression. Then you could just create your repository and define a find method with a return type of this DTO class, and Spring Data JPA would automatically generate the constructor expression. So this is basically the same code as we had before. The only difference is that we now don't specify the query. We use Spring Data JPA's derived query feature, which generates a query based on the method name, and in this case also based on the return type that we have here, the author summary DTO. With this approach, you still need a class, author summary DTO. But with Spring Data JPA, you can even remove that class and replace it with an interface. As long as the interface has getter methods that use the same name as the getter methods in your entity class, then you don't need to even need to provide the DTO class. The only thing that you do is you define an interface with a few getter methods, and Spring Data JPA generates all of the rest. And yeah, right. These are the standard things that you can do with Spring Data JPA. You can now combine multiple interfaces. You can use expression languages and all other kinds of things. But I think for this stream that should be enough details for now. I will add the link to the chat, Spring Data JPA projections. If you want to dive deeper into that, take a look at that article. And well, if you have any questions, post a comment on that article or on the on this week's live stream video on YouTube, and I will do my best to answer the question in the next live stream, which will be next Friday. By the way, if any one of you has a topic that you want to learn about, and that might be a good topic for the next live stream, please post it in the chat. If you have any topics that you're especially interested in, then I'm more than happy to talk about them in the first part of one of the next streams. And if not, then, well, then I pick a topic and you just have to live with it. But I hope that over time we will more and more get suggestions from you or other people in the community what you want to learn about. Okay, then we have Nenad. What is the difference between using an entity manager versus repository to persist an entity? Is there any benefit of using entity manager or repository? Well, there isn't really a difference between that. The repository is a little bit, or some people say a little bit easier to use, but well, the only thing that Spring Data JPA does, and you have to put the only thing into air quotes in this case, is Spring Data JPA provides a layer on top of JPA with the goal to integrate JPA into the Spring world and to solve a lot of usability flaws and to reduce the amount of boilerplate code required to use JPA, and they do that very well. And well, in the case of persisting an entity, there isn't a huge difference because there is not a lot of boilerplate code required by the JPA specification. So in both cases, you would instantiate an entity object, and you either provide it to the save method of your repository or to the persist method of your entity manager. And well, in the end, both of them do the same. The repository provided by Spring Data JPA also only takes that entity object and provides it and calls the persist method on the entity manager with it. Does a few smaller things before that, but performance-wise, that basically has no relevant effect. So yeah, you could say there is not really a difference. You will recognize the difference between using the entity manager directly and using a repository when you start writing queries. Or if you want to, well, if you want to use different projections, as we did in the example that I just gave you with the DTO projections, or if you use things like entity graphs, for example, all of these are much easier to use with Spring Data JPA. But in the end, it's still just the JPA feature set that we have there. It's just added functionality on top of that. Yeah, I hope that answers your question. Nikolai wrote, pessimistic logging would be a great topic. Yeah, you're right. That would be an interesting topic. Maybe we use that as a topic for one of the next streams. It's also a topic of the advanced and the performance tuning video course that I'm offering on my site. So I will need to take a look at that and how these topics overlap then with the stream. But I'm more than happy to give an introduction to the pessimistic logging part. But I hope you understand that every now and then there is a topic that is just exclusive for the course content in some way or form. But yeah, as I said, I'm more than happy to give an introduction to pessimistic logging. Petros wrote, what about auditing with Hibernate? And he means more advanced than what I already gave on my blog. Well, auditing with Hibernate, there are different ways to do that. Option one is to just not do that with Hibernate in general, but to move it to the database or an external system or stuff like that. Or if you want to do it with Hibernate, then you could use Hibernate Envers, and Hibernate Envers provides you with an API to query your log with a few entity listeners that automatically write all these log entries. Yeah, that could be a topic for one of the next streams as well. I will write that down and see what we can do in a 15-20 minute presentation. So an hour-long talk about Hibernate inverse would probably bore a few people, because I know that's not the most requested topic, but I think it's definitely interesting, and it's definitely a topic that more people should know about, because Hibernate inverse, if you're using Hibernate, is really nice. So yeah, I would look into that and see what we can do in a 15-20 minute session. Probably with a focus on retrieving data from your audit log, because that's the part that's really interesting. You can create pretty complex queries where you can see, for example, you can go back in time to, I don't know, the 1st of December 2020, and then check which book had a comment from a specific user that used a specific set of words or something like that. That is interesting, and that provides quite an interesting feature set for rather complex use cases. They were used in a few projects to implement rather challenging user requirements. Okay, so I keep in mind that you guys would like to talk about pessimistic logging and about auditing, and we see when we can do a stream about these two things, and then we see what we do afterwards. Yeah. So next week's stream will be on Friday at 3 p.m. And well, based on this input, I need a day or two to think about the topic for next week. Especially the Hibernate inverse part could require a little bit of preparation. So maybe this is a topic for the stream in 2 weeks rather. And then I will announce the stream on YouTube on Monday or Tuesday. And I hope to see you again next Friday at 3 p.m. CET. So basically the same time as today. Okay, have a great weekend. Thanks all for joining and for asking questions and everything. I hope you enjoyed it. If you want to catch the replay of the stream or any additional information, then please go to thorbenjansen.com/live. There you find a list of all live streams, or join my YouTube channel to get a recommendation, get a notification about new videos and live streams. Okay, now I see there's a few things in the comments. So Jagannatha asks, any thoughts on the performance improvement over implementing a custom proxy object for DAO classes? Any thoughts on the performance improvement over implementing a custom proxy object? So that's probably in regards to a Spring Data JPA repository, or I'm not exactly sure if I understand that question. Oh, Nimad suggests as a topic, implementing soft delete on entities. Yes, definitely. Yeah. Jagannatha, could you please post this as a comment in the chat? No, as a comment on this YouTube video after I closed the live stream. then I will make sure to write you an answer or answer it next Friday. And okay, I will add the third topic suggestion from Nima to the list. So we have pessimistic logging, auditing, and implementing soft deletes. And yeah, thanks to everyone else. Thanks for joining. Have a great weekend. Bye.